Hello everyone, my name's Richard-Bollans and today I'm going to be presenting some work that I've been doing with Lucia Gomez-Alvarez and Tony Cohn, looking at the notions of categorisation and typicality in the context of spatial referring expressions, and in particular the influence of object-specific features. So for some background, we're looking at modelling the spatial prepositions in, inside, on top of, over, above, under, below and against, and considering their semantics in situated dialogue. So I thought that the notions of categorisation and typicality may be distinct for spatial terms, and that this would influence how they should be processed in dealing with referring expressions. One way I believe they may differ is that object-specific features may be more salient in categorisation and less salient in typicality judgments. So we conducted a study to test this hypothesis. To first clarify what we mean by categorisation and typicality, a category decision is when an entity is labelled with a category or concept and the judgment isn't made in direct comparison with another entity. And we contrast this with the notion of typicality, and we ground the notion of typicality in comparison and preference. So we say an entity X is more typical of a concept than an entity Y if, when X is compared with Y, people in general pick X as a better category member of X, as a better member of the concept. With regards to referring expressions, we can imagine that it's important to model categorisation when trying to produce natural utterances, and that typicality is more important when trying to interpret utterances. It also appears that some sort of recursive reasoning should be modelled when handling referring expressions. So for example, listeners should also model categorisation in order to better understand the intentions of the speaker. In general, if these two notions are distinct, it's important to model them appropriately. So we're looking at the influence of object-specific features on these category and typicality judgments. It appears that various object properties and affordances influence the categorisation and usage of spatial prepositions, and we call these object-specific features. To give a couple of examples, whether or not the ground is a type of container appears to influence the usage of in. So we tend to use in if the ground object is a container, but we won't if it's not a container. For the prepositions over and under, whether or not the figure or ground is a type of container, or the figure or ground is a type of covering object. So for example, we may say a lid is over a pan, or the pan is under a lid, or someone is under a roof if they're sheltering under the roof. For the preposition against, whether the ground is fixed relative to the figure appears to be salient. So if we have a figure object that's mobile and a fixed ground object, then against is appropriate when describing some sort of contact relation. Compared to when the figure is fixed but the ground isn't. So we can say things like the bike is against the wall, but usually you wouldn't say the wall is against the bike. To introduce what motivated this study, so in some previous work we collected categorisation data and translated this into a model to process referring expressions. So if we look at the example in figure 1 from this previous work, people were more likely to label the cube cup configuration with the preposition on than pencil cup. But when given the description, the object on the cup, people were more likely to select the pencil rather than the cube. And this sort of suggests a divergence of category and typicality judgments. Also in some other previous work we generate a model which performs particularly well at answering these types of descriptions, like the object on the cup, and the model works by generating a measure of typicality of given configurations and picks the configuration with the higher typicality score, and in general it agrees with participant judgments. In figure 2 we have we're using a slightly refined version of a model, but if we plot the typicality measures given by the model, which are assigned to configurations, against the likelihood that the configurations are labelled with the preposition, we get the plot shown in figure 2. This is for the preposition on. So clearly we can see correlation between the typicality measures from this model and the likelihood of categorization, but there are lots of examples where with pairs of configurations where one would be more typical and the other seems to be a better category member. So the hypothesis that we're testing in this paper is that categorization and typicality judgments differ in the following way. So given configurations C1 and C2 and some preposition, participants may be more likely to categorize C1 with the preposition, yet be more likely to say that C2 is a more typical instance of the preposition. In general, we expect that this arises as object-specific features are more salient in categorization, while geometric and physical relationships are more salient in typicality judgments. So if we look again at the example from the previous slide, the pencil cup configuration appears to be more typical, while the cube cup configuration appears to be a better category member for the preposition on. So the current paper is intended to test this more rigorously and with more examples and more in depth. So to test this hypothesis, we created a framework to collect data using virtual environments built in Unity 3D. We created 2 tasks to compare participant judgments, a categorization task where participants are given a configuration and asked to say which prepositions are appropriate, and a typicality task where a description is provided and participants need to select the best fitting configuration. Using this data, we can compare configurations and identify if one or the other is a significantly better category member or is significantly more typical. Okay, so we conclude from the study that we can't verify the hypothesis from the collected data. As in this data set, we didn't find any pairs of configurations where one configuration was a significantly better category member and the other was significantly more typical. However, this was a relatively small data set which could be extended to test this further. One possible reason that we didn't find any significant differences is that object-specific features may be salient in both category and typicality judgments. I'll give an example of this here for the preposition on from using a couple of configurations from our study. So if we look at figure 5 and 6, these show configurations that were tested in the study. If we consider the usual physical relationships that define the preposition on, so support, contact, and the degree to which the figure is above the ground, it seems that the pair bowl configuration in figure 6 should be a better instance of on. This is because the pair is fully supported by the bowl, while the mug is leaning on both the pencil and the table. There's also a high degree of contact between the pair and the bowl compared to the mug and pencil. Also, the entirety of the pair is above some part of the bowl, and some part of the pair is above the top of the bowl, while the bottom of the mug is level with the bottom of the pencil. The particular object-specific feature that's being tested here is the role of the bowl as a container. So usually on isn't used when the ground object as a container. So if the hypothesis were correct, we would expect that the mug-pencil configuration is a better category member, and that the pair-bowl configuration would be more typical. However, the mug-pencil configuration was found to be a significantly better category member and significantly more typical than the pair-bowl configuration. There's some more similar examples of this from the dataset and in the paper, and I think these suggest that object-specific features are salient in both category and typicality judgments. So to summarize, category and typicality judgments may differ for spatial concepts, and appropriately modelling these notions is important for processing referring expressions. From our collected data, we can't verify that these notions differ based on object-specific features. However, our data hopefully highlights the importance of including object-specific features in semantic models. Thank you for your time. I'm looking forward to any questions and comments.